Caution, please be excused for the terrible drawings in the upcoming video. Looking at the giant ball of gas in the sky, we often wonder what's going to happen at the very end of its life. Will it explode into nothingness, or will there be some remnants? Even though our sun is relatively huge, it is still considered a low mass star. What even is a white dwarf? According to the cosmic perspective, it is the original core of a star, while the outer layer has shed into a planetary nebula. They are quite tiny and start off quite hot, but cool later. And they are very, very dense. In fact, a teaspoon of white dwarf material is equivalent to a couple tons of Earth material. So we decrease the radius and increase the mass, so the gravity has gone up. But why doesn't it get crushed by the sheer amount of force? Inside, there is an outward force called electron degeneracy pressure. Once energy levels are filled, there is more and more buildup, causing a pressure outward. Now on to discovery. In 1844, the thought of existence of a white dwarf was by Frederick Bessel, who thought there must be something here. However, Alvin Clark in 1863 confirmed it with his own eyes. It was noticed that a star called Sirius had abnormal movements, so a white dwarf near it, Sirius B, was the cause. One way to observe white dwarfs are through the Hubble telescope. This is what the Hubble telescope sees in a constellation, and all the red circled dots are white dwarfs. X-rays are also used, such as the Rosat satellite. They can almost see right through the gaseous layer of the white dwarfs, and they see the dense, ultra-hot innards. Now, for an example. After a red giant turns into a planetary nebula, a white dwarf is often seen. Here, the Helix Nebula in Aquarius has a white dwarf, and right in the middle, where the green circle is. That is the conclusion of my intro to white dwarfs.